These readouts illustrate a gap in measuring duration. Left is synchronized deep NREM sleep, right high-frequency REM. A physical clock counts 60 minutes for both, yet internal experiences diverge. NREM records no duration. REM feels longer than the physical hour. During deep NREM, the brain enters a highly synchronized, undifferentiated state. Without distinguishable changes in the continuum, there are no internal markers to distinguish before from after, and psychological time effectively vanishes. REM sleep functions differently. Characterized by rapid state transitions and dense narratives, this high rate of internal change generates an expanded, elastic sense of time. These divergent states suggest that we don't experience the uniform passage of planetary cycles directly. Instead, our sense of time is an inference drawn from internal regulatory transitions. In this view, time perception is an active, internally generated metric, a measure of how a biological system organizes its own changes. Most of us rely on a simple heuristic to explain why this internal clock speeds up or slows down, assuming it's a matter of emotion. We assume that time flies during positive experiences and drags during negative ones, treating our emotional state as the primary throttle for time perception. However, continuity theory and the Brain Kinematics Model suggest emotional valence is merely a correlate. It accompanies the change in time, but doesn't cause it. The actual mechanism is a strain arc, a structural trajectory that every cognitive process follows from initiation to completion. The driver of time perception is the ratio of structural progression to unresolved recirculation within that arc. Physics has historically treated time as an independent parameter, or a feature of spacetime geometry. Einstein's equations show that elapsed time depends on an observer's trajectory through spacetime, yet these formalisms remain centered on physical coordinates, leaving the biological state of the observer out of the calculation. Continuity theory approaches time from the opposite direction. It posits that a completely static continuum, one with no sensory shifts, memory updates, or internal flow, contains no detectable time at all. If the state of the continuum doesn't change, there is no now to compare against a then. In living systems, the brain is never static. It continuously oscillates between states, seeking a homeostatic balance through regularity minimization and maximization. These transitions allow us to formulate time as a rate, the amount of change in the continuum divided by the speed of those changes. From this perspective, psychological time is a measure of how quickly a system traverses its own internal state space. The Brain Kinematics Model views every thought and goal as a movement through this state space. Every cognitive process follows a strain arc, from an initial spark through growth and climax to resolution. We experience time based on our current position. This continuity time is the distance the continuum has traveled through its strain configurations. If the brain loops around a high-amplitude theme without advancing toward the end of the arc, it enters a state of recirculation. Progression occurs when the brain moves efficiently toward the climax and resolution of the theme. High progression compresses our sense of duration, while high recirculation stretches it out. We can test this by isolating emotional tone from structural progression. Take the example of a child waiting for their birthday. The emotion is positive, but the mental theme is stuck in a loop. The brain is repeatedly checking a prediction. Is it time yet? Without moving toward resolution. This high recirculation expands the subjective hour. Compare that to a surgeon performing an emergency procedure. The situation is highly stressful and the emotion is negative, but the cognitive state involves continuous problem solving and rapid resolution. This high progression rate compresses the entire experience, making the hour seem to vanish. These examples are explained by a single relationship. Psychological time is proportional to image amplitude, emotional intensity, and the distance from resolution, all divided by the rate of progression. The rate of progression toward resolution is the dominant factor. It overrides the emotional tone in determining how we feel the passage of time. This same rule applies to the temporal distortions we experience while dreaming. Searching dreams, where you are trying to find a room or missing a train, are defined by unresolved strain. Because these dreams feature high image amplitude and endless recirculation with no resolution, subjective time stretches. A dream that lasts minutes can feel like hours of searching. Resolution dreams, such as reaching a destination or reuniting with someone, follow a different path. These involve continuous advancement along the strain arc. As the theme reaches resolution, dream time appears to flow smoothly or even contract. This suggests that waking time and dream time are not different phenomena. They are simply different coordinates on the same continuity spectrum. This process of calculating state transitions is distributed across the brain's architecture. The hippocampus handles the psychological past by maintaining and organizing memory traces. The parietal cortex integrates current sensory information to generate the psychological present, and the prefrontal cortex projects a psychological future through its predictive models. The flow of time is the result of these regions working in a unified loop to process strain. Conscious time depends on the coherence of this tripart system as it moves the continuum through its state changes. From deep creative flow to the loops of anxiety or the elastic narratives of a dream, the underlying mechanism remains the same. The brain generates time as an emergent output of its own regulatory activity. This relationship is governed by 4 variables: regulation, dispersion, the strength of the mental theme, and its image amplitude. In this framework, our experience of time is a direct reflection of how a biological system navigates the opposing forces of order and chaos to maintain its own continuity.